Okay, this is a continuation of Unit 5 Study Guide. For number 6 and 7, we have to write the quadratic equation of the graph that has been shifted vertically and compressed by a factor of 1/2. So we're going to write this in vertex form, which is a x minus h squared plus k. So if it's shifted vertically and compressed by a factor of 12, well, the compression goes in the front, so it's 1/2. Then we have shifted vertically. The vertical shifts are always the last number, so we don't have any left-right shift or horizontal shift, so we're going to just put x squared, and then it's shifted vertically by -1, so it's just -1. Okay, for the next one, it's reflected over x. That means we're going to have a negative out in the front, and then it's shifted horizontally by 2. So if it's shifted horizontally by 2, we're going to put the -2 because it's the opposite. And then we have no k, so we don't put anything. Okay. For the next one, it says change the equations to standard form. What you need to know is that you have to FOIL these. Remember, first, outer, inner, last. So you're going to FOIL. Okay, then you're going to distribute whatever's on the outside. So you always FOIL first, then you distribute. Okay, let's try number 8. So if you want to put these in standard form, remember standard form is ax squared plus bx equals c. So we're not going to distribute 3 first. We're going to take that x minus 1 and x plus 2, and we're going to FOIL that. So first we're going to multiply the first, so x times x, x squared. Then we're going to multiply the outer, so x times 2, that's 2x. Then we do the inner, which is -1x times x, so it's -1x. And then we do the last term, which is the -1 and 2. So -1 times 2 is going to give you -2. So now we're going to combine those. So x squared plus x minus 2. Okay, so now we can't forget about our 3. Now we can distribute the 3. We're going to distribute the 3 to everything. So we have 3x squared plus plus 3x minus 6. So you should have gotten 3x squared plus 3x minus 6. And if you want to check yourself, you can always pop this into y equals into your calculator, and then also put this into y equals in your calculator. So you would plug this in for y1 and plug this in for y2, and both graphs should fall on top of each other. Okay, so number 9, we're going to do the same thing, but you have to look at, if it's in vertex form, that means that we have to write x plus 4 and x plus 4 twice because it's squared. Okay, and then we can't forget about the -6x or the negative on the outside. Okay, so first, and we're only going to distribute this negative on the outside of these. So after we FOIL, we'll distribute the negative, and then we'll go and subtract the -6x. So if we FOIL it, x times x, you get x squared. Then we do the outer, So x times 4 is 4x. Then you do the inner. So 4 times x, you get plus 4x. And then 4 times 4, you get 16. So you should get x squared plus 8x plus 16. Now you can distribute that negative that you had on the outside. So negative x squared minus 8x minus 16, and then you have to subtract that negative 6x. So this changes when we subtract that from here. Negative 8 minus negative 6 is going to give us a negative 14. So our final answer would actually be negative x squared minus 14x minus 16. And you can also check that by plugging this into y equals 1 and this into y equals 2 to see if they match. Okay, now we're going to go over 4 problems from blast from the past. So these are inequality problems 10 and 11. We have to describe the graph. So you know you have to get the variable y by itself. So we're going to divide by negative 5. But when we divide by negative 5, you have to remember you have to divide each of the terms by negative 5. So then you'd end up with y. And then we have to change that sign because we're dividing by negative. So we're going to flip it. And then 5 divided by negative 5 is going to give you a negative x. And then you're going to get 20 divided by negative 5, which is negative 4. So it says describe the graph. So your y-intercept is going to be at negative 4. And then it's going to be shaded above, and it's going to have a dashed line. And just remember that the inequality that doesn't have a line underneath, that tells me it's a dashed line. It's shaded above because my little inequality sign is eating the y. So you can just imagine a little Pac-Man or alligator is eating the y. And then this is your y-intercept. And then your slope would be down 1, negative 1. So if you had to sketch the graph, you'd be able to sketch it. Now number 11 is a little bit different because it doesn't say y equals. It says x. So you don't have to get the variable by itself, but in order to sketch it, I would definitely draw a graph, and then you're going to find 5 on your graph. And this is going to be a dashed line because there's no line underneath. And it says that x is greater than 5. So you would shade everything greater than 5. So all these numbers over here are greater than 5. So it would be a vertical line shaded to the right. And don't forget to actually put dashed because it's dashed and vertical. Okay, so for 12 and 13, you're going to find the rate of change of the functions over the given interval. So we know that we are basically using y2 minus y1 over x2 minus x1. And for these, we already have our x values. So in our 2 coordinates, we have the x values. We have to figure out the y values. Same thing over here. You have to find the rate of change. You already know the x values, 0 and 4. Okay, to find the y values, you can either plug this into your calculator or you can actually do the math. We're going to take the -1, plug it in, so I can find my y values. So I am plugging in -1. -1 squared is just going to give me a 1. And 2 times 1 is just 2. And 2 minus 4 is going to give me a -2. So this gave me a -2. And then I'll do the same thing for 4. Plug that in. So I plugged in 4. I got 4 times 4 is 16. So 2 times 16 gives me 32 minus 4. Okay, so if you do 32 minus 4, that's going to give you 28. So the y value here is going to be 28. And now you can do the x1, y1, x2, y2 formula to figure out what the average rate of change is. So that means you would do 28 minus -2 over 4 minus -1. We're subtracting negatives, so we change those to positives. So then you get 30 over 5. And 30 over 5 is going to give you 6. So the average rate of change would be 6. Okay, for the next one, it's already graphed. So this is going to kind of make this easier on us so that we don't have to do all the work like we did over here. If we have a graph and this equation is already graphed, we can just look at like the graph on 0. So the graph on 0 is at 0, -1. So just put -1. And then the graph on 4, if you look down on 4, is going to be at 4, -9. And you can always pop this equation into your calculator and look at the table of values just to make sure that those two are accurate. So we're going to put -9. We're going to do the y2 minus y1 again. So x1, y1, x2, y2. Then we do -9 minus -1. Okay, and then we can see that negative minus a negative, that's going to give us a positive. So -9 plus 1 is going to give us -8. And then 4 minus 0 is going to give us 4. So our average rate of change would be -2. And that's just telling us that from 0 to 4, so this part of the graph, the average rate of change, that means on average, average rate of change would be -2. Okay guys, make sure you study and organize your notes. Good luck.